In this video, we introduce the Neo4j graph database browser as an interface for accessing ComptoxAI's knowledge graph. You can reach the public-facing instance of this browser by either navigating to it on the ComptoxAI website or by entering neo4j.comptox.ai in the address bar of your web browser. Alternatively, you can access it through the website itself by clicking on Browse ComptoxAI Data, scrolling down and saying Launch Neo4j Browser. Note that no authentication is required to access the graph database. You can either simply leave the username and password fields on this page blank, or you can change the authentication type to no authentication. Then hit the Connect button to proceed. As a side note, future releases of the Neo4j browser software should allow users to skip the authentication screen entirely. So now that we're at the home page for the graph database browser, let's start by just running a simple query to fetch 10 chemicals from the knowledge base. We can do that using the following query. What this says is we're going to match chemical nodes in the graph and bind those to the variable C. Then we're going to return anything that matches into C, but limit it to 10 records. You can hit the play button to see the results. Now we can see that there's a representation of the returned chemicals in this instance in this frame here, which we can expand to show more of the screen. We can also view these in tabular format, in text format, or in code format. In any graph visualization, you can click on nodes or edges to see their attributes. For example, if we click on this chemical here, we can see the attributes in the right panel. You can also expand or collapse all of the edges that are incident to a given node. For example, this chemical node had these other incident edges to it. We can collapse these by clicking on the button again. We can continue to go outward to build larger graphs in this way. When we're done with a query, we can close out of that query's results to free up browser memory by clicking the X. We can also receive a random sampling of nodes by clicking on the node label over here in the Database Information tab on the left hand of the window. So for example, for chemicals, we can do this. Now let's look how to retrieve edges in particular. In this case, we're going to run a query for 3 edges with the label gene in pathway. We can do that with this query. So we're specifying a gene as the starting point of an edge, then a relationship with the label gene in pathway. You'll notice that it gives us some autocomplete options along the way. And then the destination of the edge will be pathway. We'll say return GRP for the gene, the edge, and the pathway, and limit it to 3. Now what we can see is that the network diagram that resulted showed an actually a merged instance of the 3 edges and all of their incident nodes. Similarly, we can access the same results in the tabular, the text, and the code fashion. Now, let's see how we can use Cypher to filter matched nodes or relationships. In this case, we'll run a query again for a chemical, but in this case, we're going to filter it so that we only have nodes with the common name PFOA, which is short for perfluorooctanoic acid. We can do that by specifying this filter here. So common name is the property, and the value is PFOA. And we're going to return the result. You can see we identified PFOA here in the result. And we can expand that graph to see its incident edges. Note that there may be more incident edges than the ones that are shown on the screen because of the fact that the browser limits the number of displayed nodes and edges to reduce memory footprint. Now, the public version of ComptoxAI has several plugins installed that can help users perform more complex operations on the knowledge graph. For example, we can use the apoc.path.spanningtree procedure to construct the network community surrounding one or more nodes of interest. In this example, we can do exactly that for an adverse outcome pathway node. Notice how we refer to the node in this example by its numerical node ID. To do this, we say call, and then we say the name of the procedure, and then the first parameter is going to be the node ID. The second parameter will be configuration values. In this case, we're saying max level is 3. We then say yield path to return the results of that procedure to the next clause, and then return path. You can see what we received is a network context surrounding the adverse outcome pathway node that we originally queried with this ID. Now let's say you don't know what that node ID is. We can instead edit this query to give us something that is a little bit more readable by chaining together queries that give us that result. So to do this, we're first going to match the AOP node corresponding to the node that we're looking for. So we're going to say, give us the AOP that we have with the ID 7. And then we say with A to return this node as the variable A to the next clause in the statement, call the procedure. The first parameter, instead of the node ID, will be A, the node that was returned from this search. Again, we're going to set max level to 3. Yield path, return path. And this gives us the same result that that previous query did. You can filter by other values as well, depending on the particular use case you're working with. So this introduction only scratches the surface of what you can do in the Neo4j graph database browser. Neo4j publishes a wealth of educational material and documentation on their website at neo4j.com.